out the value of a polynomial at a particular value of the variable. So let's say our polynomial is px equals 2x power 4 plus 3x cubed minus x squared plus 5x plus 10. So on purpose, we have written a little bit of a bigger polynomial. And instead of writing a smaller linear polynomial or a quadratic polynomial or a cubic polynomial, now let's find out the value of this polynomial at, let's say, a value of x, let's say at x equals 1. So the way we do that is wherever we have the variable, we replace the variable with the value. So we have p of x. So instead of writing x, we will write p of 1 or p within brackets 1 equal to, the first term now look like 2 times x power 4 becomes 1 power 4. Then plus 3 times x power cube power 3 becomes 1 cube minus 1 square plus 5 times 1 plus the number 10. And when we calculate this, we see it is 19. So we say that the value of polynomial at x equals 1, which is represented by p within brackets 1, is equal to 19. So similarly, if we were to find out the value of polynomial at x equals 2, so that will be p within brackets 2 will be equal to 2 times 2 power 4 plus 3 times 2 cube minus 2 square plus 5 times 2 plus 10. And when we calculate this, we will see this particular value is 72. So how about at x equals 0? That means the value of polynomial at x equals 0, which will be p within bracket 0. It will be 2 times 0 power 4 plus 3 times 0 cube minus 0 square plus 5 times 0 plus 10, or simply the number 10. What about the negative values of x? Again, it will be exactly the same thing. So it will be 2 times minus 1 power 4. This time we're trying to find out the value of polynomial at x equals minus 1. So it will be 2 times minus 1 power 4 plus 3 times minus 1 cube minus minus 1 square plus 5 times minus 1 plus the number 10, which will be equal to, now when we solve this, we will get 3. And one last example, let's say the value of polynomial at x equals minus 3, which is represented as p of within brackets minus 3. It will be exactly the same way that we have done it 4 earlier times, which will look like this, and the value will be 67. Now, sometimes and we will see this in the next few videos, when we find out the value of polynomial at different values of variable, we can write them in a little bit more compact form as something like this. So here we have a simple table with 2 rows. The first row represents the value of the variable, which is value of x, and second row represents the value of the polynomial, which is value of px. So the first column here is the value of the variable. So when the value of the variable was 1, we found out the value of the polynomial was 19. When the value of the variable was 2, value of the polynomial was 72. Similarly, 0, it was 10. When the value was minus 1, px was 3. And when x was minus 3, px was 67.